This is a super popular misconception in math. If for all sets A, B, and C, if A is a subset of the union between B and C, then A must be a subset of B, or A must be a subset of C. So why do I say this is a common misconception? Well, let's draw what this statement is really saying. Okay, so if we have A being a subset of B union C, it means we cannot have any part of A like this that is not in B or in C. So that means that we want to get rid of this region right here. So this then leaves us by saying A must be the set in the following shape like so. This then becomes our set A. It's going to be everything inside this like 8-figured kind of shape, the shape that looks like this, right? This is going to be our set A. Now, of course, ignore any spaces I made here. It's just so you can maybe a little more clearly see the sets A, B, and C. I didn't want to color over those lines, but you get the point. This is our set A. So what does it mean to then see, well, is A a subset of B? Well, for A to be a subset of B, it means all of A has to be in B. It means every element in A must also be an element in B. Okay, well then let's have a look. Where can A have elements? A can obviously have elements here, right? That still is an element in B. A can have elements here, that's still going to be an element in B. Can have elements here, that's in B. Elements here, that's in B. But A can also have elements here. But if A has an element here, then that element is not going to be in B, right? That element is in C. It doesn't share anything with B. Similarly, if A has an element in that region, then A also doesn't have an element in B. That element that A has is only going to be in C. So this is not going to be true. It's not true that all of A is going to be in B, or A is going to be a subset of B. Okay, well, for an OR statement to be true, you just need one of the two things to be true, right? So maybe A is a subset of C. Well, similarly, for A to be a subset of C, it means any element in A must also be an element in C. And as we can see here, these 4 areas, if A has elements here, they will be in C. But A can also have elements here which are equally valid, but these elements are not going to be in C. So we know that's also not going to be true. You can have a set A where not all of its elements are going to be in C, or not all of its elements are going to be in B. So this makes the statement false. So now let's go ahead and prove that this statement is going to be false. So to prove a statement is false, we have to prove its negation. Now this is a for all statement. So the negation of a for all is going to be a there exist. There exist sets A, B, and C that follow this rule, but don't follow either one of these. So this means we need to prove the following statement. There we go. We have to prove that there exist sets A, B, and C such that A is a subset of B union C, but A is not a subset of B, and A is not a subset of C. Notice here how I used an and here we have an or. Because for an or statement to be true, you have to have at least one of the two things to be true. You can have B, the A be a subset of B true, and this be false, or you can have this be true and this be false, or you can have both of them be true. So what is the only way for this to be false? It's for both of them, for this and this to be false. So that is why we wrote that in our negation as an and. Okay, so we have to prove the orange statement is true to then prove the black one is going to be false. So this means that we have to come up with examples of A, B, and C such that this is true, but this is going to be false. Let's redraw our diagram very quickly to help us come up with examples of sets A, B, and C. Okay, so here is our set that would meet this condition. All of A is a subset of B union C. So this means we have to come up with a set A where it has elements in this region and it has elements in this region, right? That's what we concluded would make both of these false. Because if we have an element here and an element here, it can't be a subset of B because there's an element in C that's not in B. And similarly, it can't be a subset of C because there's an element in B that's not in C. Okay, so what could this be? Well, this could simply be saying, we can just label these elements, like that could be 1, that could be 2, or more simply, let's use some letters, right? Let's label this element A, And actually, no, we're using letters to label our sets. So yeah, let's stick with numbers. We'll label that 1 and this 2. So this means that A can have the elements 1 and 2, and B can have the element 1, C can have the element 2. Okay, well, obviously the union between B and C is going to be every element in B and every element in C, which is going to be 1 and 2, which is clearly going to be A is going to be a subset of this because every element in A, 1 and 2, is also going to be in this set, 1 and 2. Okay, and then what do we find? Well, since we found that this is going to be true, right? Well, then that means that, well, is this going to be true, that A is not a subset of B? And the answer is yes. If A contains the elements 1 and 2, since 2 is not an element of B, but it's an element of A, then A is not a subset of B, right? And similarly, A is not going to be a subset of C, because if A has the elements 1 and 2, since 1 is not an element of C, then A cannot be a subset of C. So now let's put this into proper words. So we can write down here, we can say, for example, let A be the set 1 and 2, B be the set containing 1, C be the set containing 2, or that'll be an and, right? And C be the set containing 2. Like so. Okay. Now we can say, then A is a subset of B union C, since, can we say B union C is equal to this? Let me just verify that really quickly. Okay, so I just checked, and yes, you can say that, since you can say that B union C is equal to the set containing 1 and 2, since it's going to be all the sets in B and all the sets in C. And then we can say, so this is true since that's true, and 1 is an element of 1 and 2, and 2 is an element of the set containing 1 and 2. So all elements in A are in the set B union C. Fantastic. So we've justified that this condition is going to be true. Now we have to show that that's true and that that's going to be true. So let's go ahead and do that. We say, however, A is not a subset of B since B has 1. So since 2 is an element of A, but 2 is not an element of B. There we go. And similarly, A is not going to be a subset of C, since 1 is an element of A, but 1 is not going to be an element of C. Fantastic. So we've proven both of these are going to be true. And now we can conclude that this makes the negation of the statement true. So, therefore, the original statement is false. Hopefully that's legible, but I've said it out loud. So, there we go. We've proven that this statement is in fact going to be false, and it's very clearly a common misconception. The trouble people oftentimes find is they say, well, yeah, there's some things in B and some things in C. But remember, for something to be a subset of something, everything has to be in B and everything has to be in C. You can't just have some parts be in B and some parts be in C. All of it has to be in B or all of it has to be in C. And since we can think of an example when it's not going to be all in B or all in C, that makes this false.